The sky turns black. Ash drifts downward like snow, smothering fields, choking rivers, and silencing entire landscapes. Within hours, day becomes night, and the air grows heavy with particles that blot out the sun. In this frozen twilight, crops collapse, temperatures plummet, and survival itself becomes uncertain. This terrifying vision is not born of imagination, but of geological history, for Earth has witnessed such moments before. They are the signature of one of the most powerful natural forces known to humankind, the supervolcano. What makes these giants even more haunting is their disguise. Unlike the iconic peaks of Mount Fuji or Mount Vesuvius, supervolcanoes rarely reveal their magnitude through sharp ridges or fiery eruptions. Instead, they slumber beneath calm plateaus, rolling forests, and tranquil lakes where families hike and travelers marvel at serene beauty. Yet under these peaceful scenes lies unimaginable power, vast reservoirs of molten rock waiting in silence. But what truly defines a supervolcano, and why should we care? Scientists explain that a supervolcano is not simply a larger volcano. It is an engine of planetary transformation, capable of ejecting thousands of times more material than ordinary eruptions. Such events are so rare that no human civilization has ever directly witnessed one, yet geological records tell us they have reshaped climates, altered ecosystems, and even challenged survival on a global scale. To understand them is to confront the very forces that make Earth both fragile and formidable. This is not merely a tale of destruction. It is also a story of science and resilience, of geologists and volcanologists who work tirelessly to read the Earth's hidden signals, using technology and reason to prepare for the unimaginable. The giants may be asleep, but humanity is learning how to listen to their breathing. What separates a supervolcano from the countless volcanoes scattered across the planet is not simply size, but scale beyond comprehension. Ordinary eruptions may devastate towns or even entire regions, but supervolcanoes operate on a level that reshapes continents and alters the global climate. Defined by scientists as eruptions capable of ejecting more than 1,000 cubic kilometers of material, they are the rarest of natural disasters, yet among the most catastrophic. To put this into perspective, Mount St. Helens in 1980 expelled just over 1 cubic kilometer of ash and rock. A supervolcano multiplies that force 1,000 times, sending shockwaves that ripple through the atmosphere and oceans alike. The most famous of these giants lie not on the fringes of our imagination, but beneath familiar landscapes. Yellowstone in the United States, stretching across serene forests and tranquil geysers, is not just a national park, but the caldera of one of Earth's largest supervolcano systems. In Indonesia, Lake Toba hides the scar of an eruption so colossal that some scientists argue it nearly pushed humanity to extinction 74,000 years ago. And in New Zealand, the Taupo volcanic zone remains a stark reminder that these forces do not belong to prehistory alone. Its last super eruption, just 2,000 years ago, darkened skies across the southern hemisphere. The echoes of these past events are written in ash layers that blanket continents, in ice cores drilled from Antarctica and Greenland that record sudden plunges in temperature, and in oral traditions passed down through generations. A villager's story of a long night or an ocean of smoke may well be the distant memory of a volcanic winter carried through myth. The Earth remembers even when we do not. For centuries, however, these scars lay unnoticed. Early geologists studying strange rock formations or vast volcanic plains often underestimated their origins. It was only in the 20th century, with advances in radiometric dating and satellite mapping, that the scale of these events began to reveal itself. Aerial surveys uncovered vast depressions tens of kilometers wide, calderas so immense that they were once mistaken for valleys or basins. It was like realizing, one geologist remarked, that the ground beneath our feet is not stable soil, but the collapsed roof of a monster. The discovery of supervolcanoes transformed our understanding of Earth's history. They are not freak accidents, but recurring phenomena, part of the planet's natural rhythm. Each eruption is a reminder that while human civilization measures time in centuries, the Earth operates on a scale of millennia. The giants we now study have erupted before, and in the span of geological time, they will awaken again. Beneath the Earth's surface lies a restless ocean of molten rock, shifting and pressurizing with every passing century. At the heart of a supervolcano is a magma chamber, an immense reservoir sometimes dozens of kilometers wide. Unlike the narrow conduits of smaller volcanoes, these chambers resemble underground seas, storing unimaginable quantities of molten material. When pressure builds beyond the strength of the crust above, the ground collapses, leaving behind vast depressions known as calderas. From the air, they appear as peaceful valleys or sparkling lakes, but in truth, they are scars, hollow reminders of ancient fury. Scientists describe this system with cautious awe. One volcanologist remarked, "It's like a balloon filling ever so slowly. We can't always see it swelling, but we know it is there, stretching the crust like fabric pulled to its limit." This analogy captures both the delicacy and the danger. Supervolcanoes don't need dramatic cones to warn us. Their danger is hidden, simmering quietly until the balance tips. Because of this invisibility, modern science relies on an arsenal of tools to keep watch. Seismographs measure subtle tremors, tiny whispers of magma shifting deep below. GPS instruments detect the slow rise and fall of the Earth's surface, movements sometimes only a few millimeters a year, but enough to reveal the breathing of the caldera. Gas sensors pick up the release of carbon dioxide and sulfur dioxide, chemical signatures that hint at unrest. And high above, satellites scan for changes in temperature, deformation, or ash plumes invisible to the naked eye. It is a global surveillance system aimed at giants that sleep for millennia, waiting for a single violent awakening. Among the most closely monitored are Yellowstone in the United States and Campi Flegrei near Naples, Italy. Yellowstone's caldera spans more than 70 kilometers, a reminder of 3 colossal eruptions in the past 2.1 million years. Visitors marvel at its geysers and hot springs, not realizing they are walking across a living pressure valve. Campi Flegrei, meanwhile, lies beneath a densely populated region of Europe, where more than 3 million people live in its shadow. Known to locals as the Burning Fields, it has produced smaller eruptions in recorded history, yet its true potential remains a source of deep concern. A scientist based in Naples explains, "We're not asking if the volcano is dangerous. We're asking when and how much warning we'll have." Understanding how a super eruption unfolds is a lesson in extremes. First comes the rise of magma and gas, stretching the crust until fractures open. Then, with terrifying speed, the chamber collapses inward, releasing pressure in an explosion that dwarfs anything humanity has witnessed. Ash clouds climb into the stratosphere, spreading across continents. Pyroclastic flows, torrents of hot gas and debris, race across the landscape faster than a jetliner. Sulfur aerosols injected into the atmosphere reflect sunlight back into space, plunging global temperatures into sudden decline. In hours, a region is destroyed. In weeks, the world feels the chill. And yet, despite the enormity of these forces, their timescale is not constant. Supervolcanoes are rare, with intervals often spanning hundreds of thousands of years. This rarity is both a blessing and a curse. It means we are unlikely to face such an eruption in our lifetimes. But it also means human civilization has no memory of living through one, leaving us unprepared for its reality. As one researcher explains, we live in a short chapter of a very long book. Just because the last pages have been calm doesn't mean the story ends that way. Over centuries, myths grew around these events. Ancient tales spoke of long nights, choking skies, or gods of fire and smoke. Without science, people interpreted catastrophe as punishment or divine wrath. Today, those myths find explanation in geology and climatology. We now know that the year without summer in 1816, caused by the smaller eruption of Mount Tambora, was not a curse, but the Earth's atmosphere altered by volcanic ash. Science has replaced fear with understanding, though the awe remains undiminished. Supervolcanoes remind us that beneath our stable cities and farmland lies a restless world of molten power. The Earth is not passive ground, but an active system, shifting, evolving, and occasionally reshaping itself in ways that reset the balance of life. To study these giants is not to predict every detail, but to learn humility before forces that have shaped our past and will one day shape our future again. Supervolcanoes remind us that beneath our stable cities and farmland lies a restless world of molten power. The Earth is not passive ground, but an active system, shifting, evolving, and occasionally reshaping itself in ways that reset the balance of life. To study these giants is not to predict every detail, but to learn humility before forces that have shaped our past and will one day shape our future again. When a supervolcano erupts, the consequences do not stop at the edge of the crater. They ripple outward, encircling the globe in a chain of destruction that can last for years. Imagine ash clouds so dense they block out the sun, plunging the planet into an eerie twilight. Temperatures fall, crops fail, and the intricate web of global agriculture begins to unravel. Scientists call this a volcanic winter. It is not just a poetic phrase, it is a deadly reality where famine spreads, economies collapse, and ecosystems struggle to survive. A geologist once described it bluntly. If Yellowstone were to erupt, we would wake up in a new world, one far harsher than the one we know. At ground zero, the devastation would be immediate and absolute. Pyroclastic flows, scorching avalanches of gas and ash, would flatten everything in their path. Cities could vanish in minutes. Entire forests would be burned to ash, lakes boiled dry, and rivers choked with debris. Survivors would face a second wave of disaster, the collapse of infrastructure. Roads, power lines, and water systems would be buried or broken. Refugees would be forced to flee, creating humanitarian crises on a scale never seen before. And unlike an earthquake or a hurricane, there would be no rapid rebuilding. The land itself would be unrecognizable. Science offers hope, but not certainty. Around the world, volcanologists use satellites, sensors, and seismic networks to track even the smallest signs of unrest. These tools might give weeks or even months of warning before a catastrophic eruption. Yet preparation is a fragile shield. Evacuating millions of people across entire regions is a challenge beyond anything humanity has ever attempted. Stockpiling food and medicine for a volcanic winter is even more daunting. As one disaster planner admits, we can plan, we can model, but in truth, we are never truly ready. Still, the study of supervolcanoes extends far beyond volcanology. Their lessons echo across other existential threats. A sudden cooling after an eruption is not so different from the scenarios modeled for nuclear war, where dust and smoke might blot out the sun. The need for global cooperation in monitoring volcanic systems mirrors the cooperation required to combat climate change. In both cases, resilience is not built overnight. It is cultivated through science, trust, and preparation. Perhaps the greatest implication is philosophical. Supervolcanoes remind us of the fragility of human civilization. We build cities, cultures, and technologies as though they will last forever, yet all of it rests on a planet that can reset itself in a single violent breath. At the same time, these giants reveal the resilience of life. After every eruption in Earth's history, ecosystems have eventually rebounded and species have adapted. Humanity now faces the challenge of doing the same, of finding strength not only in our technology, but in our ability to cooperate and endure. The impact of a supervolcano is not measured only in ash and stone, but in how humanity chooses to respond. Will we see it as an inevitable apocalypse or as a test of our capacity to survive the unimaginable? The answer lies not in fear, but in preparation, knowledge, and the recognition that in facing the Earth's fury, our greatest weapon is unity. Supervolcanoes are rare, but their shadow is ever present. Unlike ordinary volcanic eruptions, they do not remind us of their power every decade or two. Instead, they sleep, sometimes for hundreds of thousands of years, silently shaping the landscapes above them. To most of us, they are invisible. Yet beneath that silence lies a reminder. Earth itself holds forces capable of rewriting the story of civilization in a single moment. As one volcanologist reflects, we study them not because they erupt often, but because when they do, everything changes. Science stands as our first line of defense. Networks of satellites, seismic sensors, and gas monitors now keep constant watch on the world's most dangerous calderas. International collaborations, from Yellowstone in the United States to Taupo in New Zealand, link scientists across borders. These systems may not prevent an eruption, but they offer precious time. Time to warn, to prepare, and perhaps to save lives. A researcher put it best. The supervolcano teaches us that survival depends on global cooperation. Nature doesn't care about national borders. Between fear and hope lies humanity's place in the story. We cannot control the Earth's deepest rhythms, but we can control how we respond to them. Knowledge, preparation, and resilience form the bridge between catastrophe and survival. If history shows us anything, it is that life adapts, and humans, with our science and our solidarity, can adapt too. And so we return to the image of these sleeping giants. They rest beneath our feet, hidden in plain sight, reminders of both fragility and strength. One day, one of them may awaken. The question is not whether we can stop it, but whether we will be ready. Because in the end, the Earth is writing the story. We are simply living in its chapters.